Okay, so if I continue this problem and I draw my line right here, and it's not a perfect world, but in a perfect world, I think this is going to intersect at 6, 3000, right there at 6, 3000. If I can get that to draw a big point. Okay. Excuse me. So I would say if I were to have drawn this on paper, it would have looked a lot nicer, but it would be 6, 3000. So that tells me that it's going to take 6 hours and 3,000 miles to catch up. Okay. So let's look at number 2. Actually, we're going to look at this really quickly. So not all systems of linear equations have graphs that intersect at one point. So the first one is an example of one solution, which is what we just had. The second one would be an example of parallel lines. That means they're going to have the same slope, but they're not going to have the same intercept, and that means it's no solution. And then if it's the same slope, exactly the same slope, same intercept, it's going to create the same line, which means it's infinitely many solutions. Okay, so let's look at number 2. We are going to graph number 2 by putting these into slope-intercept form would be the easiest way to do this. So I'm going to rearrange them both. So the first one is negative x equals negative 1 plus y. So for slope-intercept form, I usually have y on the left. So what I'm going to do is just flip this whole entire thing and put negative 1 plus y equals negative x. And then all I have left to do is add 1 to both sides to get y by itself. So y equals negative x plus 1. So if I go ahead and graph that, I put a point at positive 1 because that's my y-intercept. And then I go down 1, right 1 because my slope is negative 1. Down 1, right 1. Down 1, right 1. Down 1, right 1. I could also go up 1, left 1. And then if I draw a line through that, okay, so then the next equation, x plus y equals 4. I'm going to try to get y by itself. So I need to subtract x. So I would have y equals negative x plus 4. Okay, so again, put a point at the slope-intercept, which is at 4. Excuse me. Go down 1, right 1. Okay, and then I would draw, I can also go up 1, left 1, and I'm going to draw a line through that. Okay, so these lines have the same slope. They are parallel. They never intersect, so we would call this no solution. All right, number 3, we're going to go through the same exact process. Okay, so we need to first get the equation in slope-intercept form. So we would have to add add x over to the right. So we would have y equals, and we're going to put that in front, x plus 8. So in order to graph this, I'm going to put a point at positive 8 and just kind of estimate. Our slope is 1, so that's up 1, right 1. However, that would be really off my chart. So instead, I'm going to go down 1, left 1, and then down 1, left 1 again. Down 1, left 1. And then I'm going to draw my line through it. Okay, so then my next equation, y minus 8 equals x. I would add 8 to both sides. So I get y equals x plus 8. So if you notice, we have the same exact equation here twice. That means that if I were to graph this again, it's going to be the same thing. So I would just call this is infinitely many solutions.